All right. I didn't hear what you said, but I'll go back to the video and find out what you said.
I thought you said it wasn't on.
Had some questions over, like question 15, 16. Why some of them, so they're just sine of theta equals a ratio, and they're asking you to come up with, using the sine inverse function here, the angle that is attached to that. Now, some of these have two angles, some of them have one angle, some of them have an angle that you get right out of your calculator, the answer right out of your calculator does not work, okay? So what I want to do is talk about some of these, and then we'll get into the law of sine. But this criteria here that they're laying out in the directions is the reason for us having to do a little bit of different work on these, okay? So that requirement that your answer has to be between 0 and 180 is something that we have to pay attention to, okay? That essentially domain is something that is flexible. It's something that changes. One question might be between 0 and 180. The next one might be 0 to 360. The next one might be eventually 180 to 270, okay, or 270 to 90. You just got to pay attention to it. And the process then is exactly the same, okay, depending on what those criteria are in the problem. What we're doing, just kind of give you an idea of why this is something that we're concerned about. When we get into Chapter 7 and we start solving trigonometric equations, Chapter 7, let's say solving the trigonometric equation takes maybe 6 steps. You already know the first 5 because of college algebra and algebra 2. Okay? The 6th step is this. Okay? So we have to make sure we're able to do this for finalizing those problems and coming up with an actual solution to those problems. So the first thing to do is to realize that this is a positive number. Okay? So sine is positive in what 2 quadrants?
1, 2.
First and second, okay? So the next thing to realize is that we're going to take the inverse of both sides. So we're going to eventually end up with theta. I'm going to take the inverse of sine theta, gives me just theta. The sine inverse of 7/9 is going to look like that. And we take our calculator is going to spit back to us. I'm just going to use my handheld back here. Mode. Make sure you're in the right mode. I'm going to go in degrees just because I believe it actually tells you to write your answers in degrees here. But usually if it even does ask me to do radians, I still do it in degrees and then I convert it over. So this gives me 51.05 degrees. And then they say round, so that's where you're seeing that first angle, 51.1. Does that make sense? Okay. So where does that show up? Well, the sine inverse, remember this, the sine inverse only produces results because of its domain. It only produces results out of those 2 quadrants. Okay? They're all right with that?
Yeah.
The domain of sine inverse is -1 to +1. The range then is -90 degrees to +90 degrees, or -π/2 to +π/2 radians. So we're looking at something out of those 2 quadrants. Now, because it was 7/9, okay, it has to be, because it was 7/9, it has to be in that quadrant there. Because 7/9 is opposite over hypotenuse, and that is the only place that the sine inverse could exist. Does that make sense? And the sine be positive. If it was in the 4th quadrant, wouldn't the sine have to be negative? Wouldn't the 7/9 have to be negative? Does that make sense? Okay. So right now, the number that my calculator is giving me back is that number right there, that angle. Okay. However, if I look over here in this quadrant, and this is the quadrant that you always work with the sign, okay? If the sign is positive, I'm going to be working in the second quadrant. If this was like a negative 7/9, I would work in the third quadrant, okay? But the sign is also positive in each one of quadrant too. So this could be a 7 there, and that could be a 9 there. Does that make sense? So this angle here is also 51.1. Does that make sense? So the second theta that we're interested in would be from there to there, right? So that number right there is found by taking 180 minus 51.1. Yes?
You mean the degree symbol in the answer?
Yep. Okay. Somebody in the last class was asking, like, dude, I'm doing this right. I've entered this answer the same way 3 different times, and it keeps giving me wrong because they had 51.1 and 128.9. You got to have the degree symbol. I wish I could change that, but I can't. So I apologize for that. But so let's do cosine. Okay. So that one had 2 answers, right? We get down to cosine, change the ratio. Now we only get 1 answer. So let's talk about why we only get 1 answer. Cosine's going to have the inverse, when I deal with the inverse, is only going to provide answers from 0 to 180. Okay? This thing's stupid sometimes. 7/9. That's a positive number, right?
Yeah.
So we're saying cosine of theta, which is adjacent divided by hypotenuse, is positive, and that only occurs in the first quadrant, right? Okay. Now, it could occur in the fourth quadrant, but we'll talk about that later on. So 7/9, that would be 7, and that would be 9, right? Okay. So when we type that in my calculator, cosine 7/9, obviously it's going to give you the 38.9 number. It's 38.94. So cosine inverse of 7/9 is 38.94 degrees. So that's what this angle right here is. So obviously one of our solutions, right? Okay. Now, it asks me to find another angle between 0 and 180. Okay? Well, some of you might be saying, well, draw this triangle here. Now, why can't, so this would be 9. That would be 7. But it'd be -7, wouldn't it? Okay? So, that angle right there, that theta, does not exist because it'd be cosine of theta equals -7/9 instead of cosine of theta equals 7/9. Does that make sense? Okay. Now, some of you might be saying, okay, well, that's true, but can't I say that that's 9 there, and now come up with how big that angle is, right? Okay, so here's the argument then. Let's take, so really, I'd be taking and finding that angle there, correct? Okay, so let me pull up the calculator real quick. We'd be taking cosine inverse of 7/9, okay, and then subtracting that from 360. So get that, right? Does that make sense? So here's my question. I'll call that A. Does cosine of A give me 7/9 back?
No.
That's not 7/9?
I don't know.
That's 7/9. 0.7 repeating forever.
All right.
Okay? Why doesn't that become an answer? Okay, because this number right here, even though it generates 7/9, is not in the domain or the interval that they asked for in the problem. If the interval was between 0 and 360, that needs to be an answer. Does that make sense? Okay. So those are little things that we have to pay attention to. And it's all about knowing where the sine, cosine, tangent are positive, where they're negative, and where or what types of numbers that your inverses can spit back to you. So let's get to 118, talks about the tangent. Is that your question?
No, I was going to ask, is there any way that we can never get an answer? Where they give us one and it's not good.
Yeah, but they're not going to do that. So they could say 0 to 180, but then say like, actually, no, there should always be one. So this might explain that a little bit. So tangent theta equals negative 25. What quadrant is tangent negative in? Okay, second, fourth, right? Because all students take calculus, so it's going to be negative in the second and fourth. Okay. So let's take our calculus. So here's the thing that happens though. When we go tangent inverse of negative 25, tangent inverse's range is only for these two quadrants. So tangent inverse is exactly the same outputs as sine inverse. Does that make sense? Negative 90 to positive 90. Okay? So even though tangent is negative in the second and fourth quadrant, the calculator is only going to give you that fourth quadrant angle. Okay? And the way that it gives it to you is not going to be maybe the most preferred way. So if I type in arctangent of negative 25, I get negative 87.7. That's what I mean. It's not really the preferred version of an angle, okay? But it's unavoidable. So what they're saying, unbelievable. I don't know how many times I'm going to do that through the day. So that's ugly. Can you see that better? Okay. So that angle right there is negative 87.7 degrees. Does that make sense? Okay, that's what my calculator is giving me back. Is that angle between 0 and 180 like my answer needs to be?
I don't think so.
No. Okay. So what we need to do is we need to use some symmetry. So if I'm using the sine, I think we've seen that when we're using the sine, the symmetry we use is flipping over the y-axis, right? If I'm using the cosine, the symmetry we use is flip over the x-axis. Because tangent is equal to sine divided by cosine, we're going to do both, flip over the x-axis and the y-axis. So if I reflect that over the y-axis and then reflect it over the x-axis, that angle actually becomes that angle right there. That kind of makes sense? Okay? Anybody know what that blue angle and that yellow angle's relationship is? V? No? They're vertical. Okay? And when we talk about vertical angles in geometry, they're the same. Okay? Now remember, the negative just told me a direction, right? So I'm going to write this as 87.7. Now, my result then, the angle theta that we're interested in, doesn't that start at your initial ray and then go to your terminal ray? Again, maybe not the best color to use. I'm kind of lacking some choices here. So I'm looking at that angle right there. How do I find that theta right there? Subtract this number right here from 180, and that will give you theta. And that's then the only one that is between 0 and 180. Okay? Now, if they were to ask us, what are your answers between 0 and 360? 0 and 360, I would find that one there. I would still find the 92.3 one. But then I also need to find the one that goes from standard position from there all the way around to up here, right? Does that make sense? So I take this negative 87.7, okay, and remove that from 360. And actually what I would do is I would take 360 minus 87.7, and that will give me the one between 0 and 360. Does that make sense? Okay. If they were to change this and say, find all the angles between 90 and 270, it's the exact same work here, because that 92.3 is still between 90 and 270, right? Okay. If they said find all the angles between 270 and 360, now 92.3 is not an answer, but 360 minus 87.7 would be an answer. So it kind of makes sense to everybody? Okay. When we get down to it in chapter 7, okay, we actually start solving equations, that 0 to 180 is going to be 0 to 360. Okay. Not saying they can't go back in those and say, okay, we're only going to look at 0 to 180, but generally speaking, they look at one complete. Because usually with our periods of sine and cosine, we're going to, it's a 0 to 2 pi, so it's a 0 to 360. So that's usually what we're looking at for those. Okay. Keep working on that. Okay. I told last class, assume that it's going to be due this evening. Okay. So I want you to work on it like it's due this evening. When you come back tomorrow, there's some stuff on here that we need to talk about. Let me know, and I can push it back tomorrow evening. But assume that it's due tonight. Okay. Work on it like it's going to be due tonight. Let's talk about the wall signs. Yeah. I'm losing my voice. 4 days of not talking. Huh?
You sound like a female.
Alright, so the sine, cosine, and tangent, those only work in right triangles, right? SOHCAHTOA only works in right triangles. So it's an issue when we get to a non-right triangle. I'm not going, because we're running out of time. If you have interest in developing this rule, okay, it's a really easy development. It comes strictly from SOHCAHTOA. But what we find out is that the sine of A over A is the same as sine of B over B is equal to sine of C over C. And I don't feel comfortable just saying you can find out. So let's actually real quick do half of this. The reason this works is if I draw that altitude right there, from C down to lowercase c in this triangle, I'm going to call that, just so I don't get things confused. Usually, like in formulas, we call that H for the altitude, right? Okay, I'm going to call it like Y right now, just so H doesn't get confused with hypotenuse. Does that make sense? So call that Y. So now, let's do this. Let's say, if I'm looking in triangle number 1 here, could you say the sine of B is equal to Y over A? That'd be fair to say? Okay. If I'm looking at triangle number 2 here, would it be fair to say the sine of A is equal to Y over B? Remember how I wrote that? Do both those have Y in them? Okay. So let's do this. You either solve both for Y. I'm just going to solve one of them for Y. Can I do that? Multiply both sides of this first equation by A. And I get Y equals A sine of B. Okay. Now what I'm going to do is I'm going to take that first equation, take that right there, and we'll substitute into the second one. So that means sine of A is going to equal A sine of B over B, right? Does that make sense? Kind of divide both sides by lowercase a here. Or multiply, if I multiply by 1 over a, will that a cancel right there? Come over here and multiply by 1 over a. So that gives me sine of capital A over lower a equals sine of capital B over lower b? It's your law of sines. Okay. Do you see how it just stemmed those strictly from SOHCAHTOA? Okay. Now there is a third ratio that is involved, sine of C over C. Okay. And the way that third one is generated is you have to, and this is why I don't want to do the whole thing, you actually then draw that altitude, maybe I call that Y, and now I look at this angle, I say sine of C is Y over B, and I say sine of B is Y over C, and I do the same game that we did up there with the sine of B and the sine of A, but this time it'll be a sine of B and sine of C. Does that make sense? And I'll figure out that sine of B over B is equal to sine of C over C. Well, sine of A over A was sine of B over B, but sine of B over B was equal to sine of C over C. Transitive property tells me they all link together. Sine of A over A equals sine of B over B equals sine of C over C. And that is the law of sines. Okay? Now, if you want a more detailed, more elaborate explanation of how I get sine of C over C there's videos on my website of either me or other people explaining that. But I want you to know it's just not generic happenstance that this proportion works. It's SOHCAHTOA with a little bit of kind of relationship recognition. The law of cosines comes from something similar, but we have to use the Pythagorean theorem with that as well. And we'll talk about that maybe a little bit tomorrow. But sine of A over A equals sine of B over B equals sine of C over C. Now, there are, do you guys remember these? Do you guys remember all these triangle congruency theorems?
From geometry?
Yeah. Like side, 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 angle, side, angle, angle, side, angle, side, angle, 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 side. Oh, I already got that one. What'd you say? Angle, side, side. Okay. Now, here's the thing. Angle, side, side, if you remember, because of that word, I told you in geometry, that was an issue, right? All those other ones guarantee congruency. Okay? These four, and there's one called hypotenuse leg, which is actually this for right triangles. But these four, okay, guarantee congruency. So if I were to give you guys all like side, side, side. So if I get, like, let's say I take three measurements, 3 pieces of yarn, 3 different pieces of yarn, okay, and they abide by the triangle inequality theorem, so that they're going to make a triangle when you go end to end. And I give all of you the same 3 lengths of yarn, and I tell you, put them end to end. Does everybody have the same triangle?
Yes.
Yes. Side, side, side congruency guarantees that. If I gave you 2 pieces of yarn, and maybe I take a piece of cardboard and I cut out an angle for everybody, and I give everybody the same angle, and I say, put your angle in between your 2 pieces of yarn. Does everybody generate the exact same triangle?
Yes.
Yes. Same thing happens with angle, angle, side. Same thing happens with angle, side, angle. You generate the exact same triangle every single time. Angle, side, side. Sometimes you get the same triangle. Sometimes you don't. Okay? So angle, side, side does not guarantee congruency. But I put a block around that because we will deal with that here. They could give me these components, and we have to then talk about it. Okay? And those problems, Cole, are a pain in the angle, side, side. Okay? So that's how I remember when they give me angle, side, side, that I've got a lot of extra work. Okay? When they give me an angle, side, side situation, it's probably about twice as much work, if not more, than when they give me angle, angle, side. Does that make sense? Okay. Now, as we go through, I don't remember, or try to remember, which of these orientations the law of sines works for. Okay. What I know, and obviously we haven't talked about it yet, that these two work predominantly or only with the law of cosines. So if they don't give me all three sides or two sides and the angle in between, I know I've got to use law of sines. Okay? My suggestion to you early on, until you come to terms with that, my suggestion is always take your problem and try to set up law of sines. So I'm going to write sine of A over A equals sine of B over B. Okay? I like to have a picture, so I'm going to draw a picture here in a moment as well. But I like to see if I can use the law of sines, I'm going to go that route. The law of sines is much easier than law of cosines. So my hope is the problems they give me are law of sines. If I can fill in 3 of the 4 unknowns there, then the law of sines works. If I can only fill in 2 of the unknowns, then I probably have to use law of cosines. Does that make sense? Okay. And that might be easier for some of us to remember that than to be able to look, okay, angle A, angle B, side C. Oh, that's angle, side. So I know law of sines. Does that make sense? I think that's hard. Okay. If I draw a picture, now a picture doesn't have to be accurate. I always draw a picture like this. There's A, there's B, there's C. So A is 75, B is 60. Okay, lowercase c, remember that's always across from the angle, right? Okay, so lowercase letters are opposite the capital letter vertices. All right, so if I go through and try to figure this stuff out, 340 is a distance. I got to use 340, so that's one of these denominators. What is opposite 340? That angle there, right? Yeah. Do I know that angle? Yeah. What is it? 45? I don't know. I believe Chuck's right. So I put sine of 45 there in that numerator. Does that make sense? So I've linked an angle in the side opposite. Okay? Now, when it says solve the triangle, what that means, we talk about this in geometry, what that means is find all the missing parts. So would you guys agree that lowercase a is a missing part? Yeah. Okay. So lowercase a would be that side right there. So can I say sine of 75 over lowercase a? Yeah. Everybody okay with that? Could I also, just while we're at it, say sine of 45 over 340 is equal to sine of 60, this is lowercase b, right? Over lowercase b. So law of sines, if you're paying attention to the way it's structured, law of sines in one ratio, you're always going to be pairing an angle and a side that is opposite to it. Okay? An angle and a side that is opposite to it. Do both of those equations have only one variable? Yes. So let's cross multiply and figure out what our solutions are. If I cross multiply here, I get A sine of 45 is equal to 340 sine of 75, right? What I need you guys to remember, and this is something that we struggled with in geometry, hopefully it makes more sense now, that's just a number, right? Sine of 45, 0.707 as a decimal. Okay? So isn't that just a coefficient for A? Yeah. So how do I get A by itself then? Divide by that coefficient. Now, it's contrary to most coefficients right out in front, right? But with trigonometric ratios, logarithms, those types of things, when there's an argument, we usually write the variable in front of the coefficient. So A then is going to be equal to 340 sine of 75 over sine of 45, right? Right now, we'll take our calculator and we'll evaluate that. eventually we won't have to use a calculator. Because eventually we'll know what the sine of 75 is. It's like radical 6 minus radical 2 or 4, something like that. Kind of like what I'm going to do the second one here. And the second one, we're not going to use our calculator. Cross multiply B sine of 45. I get 340 sine of 60, right? B is going to be 340 sine of 60 over sine of 45. Everybody okay with that?
Yeah.
What's the sine of 60? Sine of 60 is radical 3 over 2. Okay. What's the sine of 45? Radical 2 or 2. And guys, that stuff will be more obvious to you when we get to chapter 6. We halfway through chapter 6. So what's 340 times a half? 170. So we get 170 radical 3 over radical 2 or 2 multiplied by the reciprocal. So I get, again, 340 radical 3 over radical 2. We can keep going. We want it to be 340 radical 6 over 2. 170 radical 6 ends up being our exact answer if we didn't make any errors there. That make sense?
Yes, sir.
Okay. So that's the idea, is that eventually sometimes, because we're going to know, now if they change that 45 to like 41, I got to write it as a decimal. Okay. Previously in the first version of that when we were finding A, they used 75, right? I had to revert to my calculator because I don't know what 75 is as an exact value. Like I said, eventually, part of chapter 7 will allow us to, might be chapter 6, will allow us to know what sine of 75 is. All right, so let's do example 2 here. I like when they give you the picture, and I think when you go through web assign, it's going to be kind of 50-50. Whether you guys draw a picture, they give you the picture. So let's solve for these things here. Right now, when it says solve the triangle, that means find angle B as well. How big is angle B here? 135? Okay. This is what I like to do. Obviously, we know sine of A over A equals sine of B over B equals sine of C over C. Just give you a couple different ways that you can organize your work. If I write all three of those ratios, you should be well on your way to being able to come up with the two equations then to use to solve. So if I go sine of 20, what should pair with 20? Okay, so sine of 20 over A, sine of 135 over B, sine of 25 over 80.4. Okay, you guys remember working with extended proportions? Okay. And we worked with them in geometry in regards to like geometric means and similar triangles, and that's what sine, cosine, tangent is similar triangles. The one ratio that the numerator and denominator are numerical is essentially your scale factor, right? Okay, so that's the one that I have to use to solve for A and to solve for B. Does that make sense? So if I go sine of 20 over A, I'm going to set that equal to sine of 25 over 80.4. Then if I'm going to go sine of 135 over B, and set that equal to sine of 25 over 80.4.
Wait, why are we solving both of them?
Because it asked me to solve the triangle. Solve for A and B.
So in math.
So what a sign will ask you. Okay, sometimes it might just give you the picture with only A up there. It'll say find A.
Okay.
The other ones will say solve the triangle, and it'll have a place for capital B, a place for lowercase a, lowercase b. On the final, it says solve the triangle, and it asks you to find them all. Yeah. Friday. So when I cross multiply, I get A sine of 25 is equal to 80.4 sine of 20. So I get something like that. Now I'll let you evaluate those on your own, but sorry for B, it should be B sine of 25 equals 80.4 sine of 135. And then divide both sides by the coefficient of B, which is sine of 25. Just to give you kind of a heads up, and then this is solely going off of previous finals for this course. The first page and a half is this type of stuff.
Oh my gosh.
They give you law of sines, law of cosine side questions. Okay. Any issues so far? We feel comfortable with this? All right. So let's talk about ambiguity. Yes. All right. So what does ambiguous mean? Say I had a friend named Pat. I just tell you I got a friend named Pat. Do you know anything about him?
No, Pat Pritchard.
Not very clear. Okay, could be a male, could be a female, right? Okay, could be imaginary. Correct?
A girl named Pat.
Okay. Yes, Patricia. Yep.
Oh, you do?
Yep. Yep. He's got an aunt named Pat and a dad named Pat. Okay? So it's ambiguous. It's not clear. It's left open to interpretation. Remember when I said side, 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 angle, side? They gave you definitive congruencies. Angle, side did not, right? So based on this information here, because this is angle, side, the 45-degree angle, a side, and a side, right?
Yeah.
Okay, where the angle is not between the two sides. This may be the one triangle, and there actually might be two, or there might actually be none. And we have to go through the work to figure that out. And my hopes are, on that logic, you can see why this is a pain in the butt. But I want to give you a picture. Okay, so let me open this from... So we won't, I doubt we get time-wise into actually doing an example here, but I want to show you the logic of angle, side. So let's say that I give you this information. Let's say that C is 7. Let's make B kind of like that. If I gave you those parts, okay? If I gave you those parts and said make a triangle, okay? I tell you have to use a 41-degree angle, and that has to be a non-included angle. So your sides cannot be both making that angle. If I do 41 degrees, isn't this row right here going to continue on forever?
Yeah.
Okay, so that's going to be my third side. But I don't know how much of that third side I need to use to make my triangle, right? So the only way that I determine how much of that third side I use is I take this other side and I start swinging it to where it touches that dotted line, right? Does it? No. So if I gave you those pieces of information, you cannot create a triangle. Does that make sense? Okay. Now if I gave you one that was, Okay, so let's make this thing, it's going to be a little off because of rounding, but let's make this 4.6. Shut up. There we go. Does it touch that dotted line? One time. And the idea is that when it touches one time, if you remember anything from geometry, this dotted line here is tangent to that circle that is formed by that radius, and when a radius intersects at a point of tangency, it's a right triangle. Does that make sense? Yeah. So with ASS, you could have one triangle like this, you could have no triangles like before, or you could have the following situation. So let's see. And the following situation, might have to mess around with to see if we'll untrace this. Standard view. All right, so let me see here. Oh yeah, it's gonna be good. So 36, and there's relationships between these angles and sides that you can learn to know automatically whether you're going to get 1, 2, or no triangles. I don't ever, to be honest with you, I don't even know what that is. I haven't sat down and figured that out. For the mere fact that the algebra to actually determine it after we do a couple steps of trig isn't all that hard. So would you agree that if I gave you those components, those two triangles right there are the same?
Yeah.
Okay. Would you agree, though, that that is potentially another triangle?
Whoa.
That makes sense? Now they're different, right? Okay. What do you think you know about, so let's look at this angle. Look at this exterior angle right here. See that exterior angle where my cursor is?
Yeah.
And this interior angle right here, right? That exterior angle just came over here. Does that make sense? Okay. So what I want you guys to understand, this is tomorrow when we actually go through the steps of solving the ambiguous case. Why do we go through the steps that we do? There's going to be a step where we take 180 minus whatever that angle right there is. And the reason we do that is because 180 minus that angle is going to give me that angle. Okay? Does that make sense? So we're going to talk about that tomorrow. But that's the ambiguous case. The potential, when I have angle side side, that information could yield 0 actual triangles. They might not make one. Okay? Could yield 1 triangle. If it does yield 1 triangle, that 1 triangle is actually a right triangle. Okay? Or it could yield 2 triangles. And that case would be what we got on the board right there. Okay? So that's what we'll introduce tomorrow. I'm going to open up 2 assignments. Law of sines, law of cosines. That's what's going to be due at the end of the week. Okay? When I'm gone Wednesday, I'm not going to give you any new assignments. So Wednesday will be a complete hour of you being able to work on those 2 things. That make sense? Okay, uninterrupted. So, I don't know yet.
Yeah, he's over there now.